Well, we are studying paired studies. Supposing we take the data, uh, the blood pressure before and blood pressure after giving treatment A, then the blood pressure after reading is dependent on the blood pressure before reading. And therefore, these two data are paired data. Supposing we want to find out how much was the improvement, then we would find out the difference between the BP before and BP after. And if there is no difference, no improvement, then the null value should be 0. Therefore, over 30 or 40 cases, we find out what is the mean difference, mean before after difference. That gives us the magnitude of improvement. And then we calculate the 95% confidence limits of that mean difference. And if that 95% confidence limits do not include 0, then the mean difference is significant at the levels of 95% confidence limits. Now, this is the analysis of paired data. But supposing we are then comparing the difference, the improvement by treatment A or treatment B, then the difference which we observe by treatment A and the difference that we observe by treatment B are not dependent on each other. And therefore, this data is unpaired data. To find out the magnitude of difference, the mean difference by A and mean difference by B will be subtracted from one another, and that would become the magnitude of difference. And to find out whether that difference is significant at 0.05 levels, we will calculate the p-value by appropriate tests of significance. And if that value is less than 0.05, we'll say that the difference is significant. Now we'll also show you how to do this calculation practically. But not only the before after data is paired, the right and left eye are paired because they belong to the same individual, and therefore they should also be dealt with in a similar manner. The measure of pairing, whether one data is paired over the other, is done by what is called as the F test, and if the value of the F is less than 3, then the two groups of data are supposed to be paired. Good morning. Let us tell you what are paired studies. So let us understand this data set first. This column says what is the ID of the patient. And let us say that these patients are glaucoma patients, and this is the pre-value of the tension recording, and this is the post value, and this is the difference. And the first 15 patients were on treatment 1 and the rest 15 were on treatment 2. Now, after having arranged the data like this, let us proceed to analyze it. So we open EpiInfo, we go to Classic, we read the file, and we say that our file is XLS file, and we browse to find where it is. It is on the desktop, so we try to search it, and this is the file that we want to study, and we say open. It says first row contains header information, we say OK. Then we go on the sheet and we say OK. Now the 30 records confirmed. Then we go for means, and we say means of the difference. Now this is regardless of the treatment type, and as we say OK, we get the mean value of the difference, the benefit, the improvement, and the standard deviation. If we multiply the standard deviation by 1.96, we will get the upper and lower limits of the confidence interval.
95%.
95%.
तभी 1.96 से multiply करते हैं.
तभी 1.96 से multiply करते हैं. And now we want to find out what this value will be in the two groups. So we go to means of, we say difference, and we cross tabulate it by the treatment type. And here's what we get. So we get that in the group 0, the difference was 6, and again 1.2649, which you have to multiply by 1.96 to get the upper and lower limits plus minus limits of the confidence interval of this point estimate. And this is the difference with the treatment 1. With the treatment 1. And we find that the difference is not really significant, and it is also shown in the p-value which we have here. So this is how paired studies are analyzed.